Okay, let's talk about connective tissue. Connective tissue is fairly different from epithelial tissues, as we will see. Um, what we're going to find with connective tissue is that there are fewer cells when we compare them to epithelial tissue. There are many fibers that are associated with that connective tissue, and we have significant amounts of extracellular matrix. Extracellular matrix. So what that means is that here's our cells. They are spaced much farther apart than epithelial tissues, and that space is then filled with extracellular matrix, which consists of fibers and something that we call ground substance. And ground substance is a gel-like substance. It's made of organic molecules, mainly glycoproteins, that fills the space. So we have cells and extracellular matrix and connective tissue. There's a lot of space between the cells that's filled with extracellular matrix and ground substance. In certain types of connective tissue, that ground substance, that extracellular matrix, can be very gel-like, and in others, it can be solid. For example, bone, that extracellular matrix and ground substance is solid. It's made of fibers and calcium salts, along with some organic molecules as well. Now, connective tissue has a variety of functions, and it depends on what the tissue is, but I'm just going to kind of mention them briefly here. Those functions include binding of organs. Now, whether that means binding organs to other organs or keeping the tissues held together within the organ itself, that's what binding would be. They play a role in support, physical protection, play an immune role, important for movement. They have storage capabilities. They can produce heat and are important for transporting of substance through the body. Now, some other characteristics of connective tissue. Vascularity. They have a blood supply. Most do. Some connective tissues do not have a blood supply. Others do. That's different from epithelial tissue, where we said that epithelial has no blood supply at all. In fact, the epithelial tissue gets its nutrients and oxygen, gets rid of its waste through the process of diffusion from that connective tissue that we find deep to that epithelial tissue. So most connective tissue has a blood supply, but not all of it. And then as far as cell division occurs, some connective tissue has regenerative capacity, others do not. So the regenerative capacity varies by the type of connective tissue. Now I keep talking about the type of tissue. Let's just kind of list them real quick here, the different types of tissues. And we can break it down into 4 groups. We have connective tissue proper, which would be true connective tissues, that they are connecting things together. We have cartilage as another type of connective tissue. We have bone as a third type, and we have blood as a 4th type. Now what we're going to find within connective tissue proper is that there are 4 different types in here. Cartilage, there's 3 different types. And we're not going to get into all of those, but I will show you some examples of those different types. Now, when we talk about the different cells that are part of connective tissue, there's a variety of different cells, each with a variety of different function. It just depends on, again, the type of tissue that these cells are found in. One of the major cells of connective tissue are fibroblasts, and these are the cells that produce the fibers of the ground substance that are found within the extracellular matrix. And there's three different types of fibers. We have collagen fibers, we have elastic fibers, and we have reticular fibers. Reticular fibers form more of a scaffolding or framework for organs to be built upon. The liver and the spleen have significant numbers of reticular fibers, as do the lymph nodes. Collagen is a fiber that is very flexible. Elastic fibers can undergo stretch, and then they're able to return to their original shape. That's what elastic means, is that something is able to return to its original shape. And so what we're going to find in the connective tissue matrix, along with the ground substance, are these different fibers. And the different connective tissues have different numbers of these different fibers based on their function. Macrophages. These are phagocytic cells. They wander through the ground substance, through the connective tissue, breaking down any particulate matter, any dead or dying cells, any bacteria that might be present. That's their job. These originally were monocytes in the blood, and as those monocytes leave the blood and squeeze into the tissues, they become macrophages. And phagocytic means that they utilize the process of phagocytosis to bring in any debris, particulate matter, dead cells, bacteria, etc. Leukocytes. These are white blood cells. Now we know that blood is a connective tissue. In fact, the cells of the blood are the cells of that connective tissue, and the plasma of the blood would be the extracellular matrix and ground substance. So these leukocytes travel in the blood. These, I mentioned monocytes, they are a type of leukocyte. These can actually leave the blood and go into tissues and perform their specific functions in those tissues. We'll address the specific types of leukocytes more when we get to chapter 18. We have plasma cells. Again, these are derived from leukocytes. So these are leukocyte derived, meaning they originate from leukocytes. And these produce antibodies, which are part of the immune system, and they help to protect you and keep you healthy. Mast cells, these are found near blood vessels. These secrete two substances. They secrete a substance called histamine, which promotes inflammation. And increases blood flow. And they also produce a substance called heparin, which is an anticoagulant. Prevents your blood from clotting. And so these are released when your body needs to increase the blood flow, and if there's some repairs that need to be made and there's damage due to some type of infection, these mast cells can release these molecules to bring more blood to the site of the injury, to promote repair and healing and further protection. Final type of cell I don't want to mention are adipocytes, and these are fat storing cells. Specifically, Triglycerides. If you think back to chapter 2, triglycerides consist of a glycerol molecule with 3 fatty acid chains, and these are stored. This is a form of energy, and these are stored in those adipocytes, and then all those adipocytes are kind of collected together in various parts of the body, and that is what forms adipose tissue, which is a type of connective tissue. All right, let's go back and address those fiber types again. I mentioned before we have collagen fibers or collagenous fiber. They're made of collagen, which is a type of protein. In fact, all these fibers are going to be made of proteins. Reticular fibers, I said, provide kind of a scaffolding for building structures upon, and we're going to find a lot of reticular fibers in the liver, the spleen, and the lymph nodes. And then elastic fibers. These are made of a protein called elastin, and these proteins are able to then be pulled and stretched, and then eventually they go back to their original length, hence the term elastic. And different tissues are going to have different concentrations of these different fibers in them.